Good morning once again, and welcome back to my YouTube channel. Now, in the previous video, we tackled coming up with the staircase, okay, incorporating our logics in loops, right, and flow control. And if we were carefully paying attention, you would realize that there's a way we can actually optimize our code. So now, if we look at the staircase I drew yesterday, right? Let me just use a simple example with the staircase, right? So we have something like this, okay? And we were using asterisks. So let me bring the asterisks. Now, you'd realize that I represented this with a grid, and I said, what we can do is we can print asterisks and print empty spaces as well, right? Now, if you were paying attention, and if some of you may have noticed that there's a way we can actually optimize this code. And how do we do that? Well, printing empty spaces is just the same as printing nothing. Okay, so if I were to clean this and see if there's an eraser. Okay, I can undo. So if I were to get rid of this, that's basically what we are doing. We are printing the asterisks without printing anything else, without printing the spaces. So we can literally get rid of printing of the spaces and then just print the asterisks. So I can get rid of this, and I can get rid of this. And when we run this, we should still get the same behavior as before. Okay. So now, someone might ask, how does this differ from the previous one? Yes, we are getting the same output. Yes, it's working fine, but I can tell you for a fact that this code is faster because we are using one less for loop, which reduces the time complexity, right, of this algorithm verifiable. That's something sort of advanced beyond what we are doing, so I'm not going to explain further. But by reducing the number of for loops that we are supposed to iterate over, we reduce the time it takes for this program to run, okay, thereby making the program run faster. Now, you will not see it for small inputs like 3, 4, but maybe for larger inputs, you will notice a significant time difference between the two programs that we just made. Okay, so I just wanted to point that out. You can run it the second time, put in, say, 10, and we're going to get this beautiful. Now, today, what we are going to be doing is different. We are going to be stepping it up a notch, right? Now, you know of pyramids, right? Okay, so what we are going to be doing today is going to be pyramids. We're going to be dealing with pyramids. Now, pyramids come in this form. So we have, let's say, the base, and we have something like this. Okay. All right. So let's just take this as our pyramid. Okay. And we have this. Okay. Now we'll have asterisks here. We'll have asterisks here. We'll have asterisks here. We'll have asterisks here, here, and here. Now, let's take this as a grid once again. So, if we assume this is a grid, what we are trying to do basically, right, is print a certain number of empty spaces before printing the next asterisk. Truthfully, we can ignore this part. Okay, we can ignore this. Now you need to focus on these ones. Okay, so what we're trying to do is we're trying to print a number of spaces before we print the asterisks. Okay, now this pyramid will be formed if the person types the number 3. Okay, so if the input, so for this pyramid that I've done, if the input is 3, we'll have a pyramid which has the height of 3. Okay, so now a pyramid with a height of 3, with what we can, how to think of this is that for a pyramid with a height of 3, we need to know the number of stars that will be on each level, or let me say each row of the pyramid. Okay, then the next thing to do is to print it, right? Okay, so based on what I've said, that means what we are doing is for each row, okay, we are printing a certain number of spaces, and then we are printing a certain number of stars. Okay, and then that's what we are going to be doing. So once we are getting the inputs, okay, which is, let's call it n. Once we are giving the input n, from there, for each row, we need to know the number of spaces we are printing, and the number of asterisks. Okay, now the question is, how do we know? For this one, when n is 3, okay, for row 1, we are getting 2 spaces. Row 1, we are getting 2 spaces, 1 asterisk. For row 2, we are getting 1 space, 3 asterisks. Okay, and for row 3, we are getting 0 space, 5 asterisks. Now you notice that the asterisks are moving in a pattern of odd numbers. Okay, so in order to get the asterisk from n and from the row 2 as well, okay, what we are going to do is come up with an algorithm that describes the number of asterisks we'll get based on the row we are on. Okay, so not based on the inputs necessarily, but based on the row we are on, because the input will remain constant. The input will always be 3, so it will not help us to vary across the different rows to get the number of asterisks per row. Okay, so what we need to do is, in calculating the number of asterisks, we need to focus on the row number. So if for row 1 we are getting 1, and for row 2 we are getting 3, for row 3 we are getting 5. This is the algorithm that points to this is the 2 times the row, okay, minus 1. So with this algorithm, we can get the asterisks. So now if you have the row 1, 2 times 1 minus 1, that gives you 1. If you have row 2, 2 times 2 minus 4, 2 times 2, 4 minus 1, that gives you 3. If you have row 3, 2 times 3 is 6 minus 1, that gives you 5. We want to take care of the asterisks. Now we need to take care of the number of spaces. Now that we know the asterisks, okay, the value for the asterisks, we can easily take care of the value of the spaces. Now the spaces will also vary based on the the row. Okay, once we are given the input, we know that. Let me just write that as well down here so that we can see that we should have did it. Okay, let me just use in a different hat. Okay, so now we can see here that for row 1, okay, I've even done that tick already. For row 1, we are getting 2 spaces. For row 2, we are getting 1 space. For row 3, we are getting 0 space. So what do you notice? You notice that if I add row 1 and row 2, I get 3. If I add row 2 and if I add row 1 in the space, I get 3. If I add row 2 plus the 1 space, I get 3. And if I add row 3 plus 0 space, I get 3. So the sum of the number of row and the number of spaces is equal to the input. So what can I say? I can say that the number of spaces is equal to the inputs, right? N minus the number of rows, the row number, the input minus the row number. And these are the two main algorithms we need to solve this problem. So what are we going to do? We are going to iterate over a loop, okay? And then within that loop, we are going to first print the number of spaces. We are going to calculate the number of spaces, calculate the number of asterisks, print the number of spaces, and print the number of asterisks. Alright, so simple as that. So that's what we are going to do. So let's go back here. Let me make this bigger. Okay. So now we don't need to get rid of this. Okay. We just need to edit this code a bit. So this thing is asterisks data stocker. But instead of using the asterisks, what we are going to be using here is the step. Okay. So let me see. Int I is equal to 1. Okay. So we're starting from 1 all the way to whatever number the person puts. I let them go to steps, right? Then I plus plus. Okay. So now the next thing is to calculate the number of spaces. And we already mentioned that the number of spaces. Okay, so instead of I, let me make this row. Okay. So the row we are on. So row 1, row 2, row 3. So this one indicates that we are on. It starts from row 1. Okay, all the way to the number of steps the person puts to first row 5 or whatever. Then we calculate the number of spaces. So the number of spaces, as we said, will be equal to, let's go back here, will be equal to n minus r, where n is the number of steps the person puts. So it will be equal to the steps minus the row. The number of space will be equal to steps, okay, minus row, right? Then we calculate the number of asterisks as well, okay, and we mentioned that the asterisks will be equal to 2 times the row minus 1. So it will be 2 times row, okay, minus 1. So now that we've done that, we'll get a loop for printing the spaces first. So we'll have for int and make this j, okay, is equal to 0, and then j less than spaces j plus plus, and then what we'll do, we'll print the space. Okay, then we have the loop for the asterisks. Int I is equal to 0, I less than asterisk, I plus plus, print f asterisk, then print a new line, and then move on to the next row. So now if we run this, Okay, we are having time issue somewhere. Okay, so the issue is with this. Yeah, I said rho is equal to 1 as I've written I. Okay, so let's change that and let's run it now and see. And another issue, J. I probably will bring this semicolon somewhere. Yes. Okay. What other issue? So now we can proceed. So let's enter. Let's try with 3. Perfection. Perfection. Now let's try with 5. Interesting. Seems to not be working when I put in the input of 5. Let's see if we can diagnose this problem and run it again. Okay, it's running perfectly. So if I run input 7, perfection. So that's how you have to do it. Take your time to break through the code and try to understand it. Now in this case, we will not optimize by removing the spaces because the space is a determining factor for knowing where to print the asterisk, right? So that's how we do it for the program. Take your time to understand this code and realize it's not so far-fetched from what we did in the previous challenge. I'll see you in the next video. Thank you. Bye-bye.